everybody. Let me just find this and see if I get it to work. Okay. So today I'm going to talk about all the activities that we do at the Planetary Defense Office, especially to focus on the ones that are more related to the topic here, to the meteor topic. I'm presenting this on behalf of the whole PDO team. So it's all activities that we do, also supported by industry. You will see that we have some activities that are not related at all, but others they are. And you have here, Detlef was the former head office, also Regina is part of the team. So we are somehow related to the meteor community, but you will see that not only we do other things. And I'm going to talk about the recent activities. So just to give you a bit of context, we are part of the space safety program. What is space safety for the European Space Agency? Is the protection of our planet, humanity, and the assets, both in space and on Earth, from dangers originating in space. That means space weather, it's space debris that we just talked about it, but also natural objects. So we have to detect near-Earth objects, trying to establish what are the dynamic and physical properties, also to assess and predict the impact risk, and then also to do some risk mitigation. And this is also where most of our meteoroid-related tasks are more or less put in terms of budget. And whenever we want to do something related to meteors, this is the main justification. Understanding how the small bodies, where most of the meteors, and fireballs are, do help us understand how a larger object would work. So these are the three pillars of how the office is organized. We do observations, we do assessments, so we work with the data to say if something is risky or not, and then we do the mitigation part. And as I said, I'm going to talk about the recent activities, what are our current plans. So we are closing observational gaps. So we are observing already for some time, but we are still missing objects. We are enhancing, upgrading our capabilities to do the orbit calculation. We keep discovering more and more objects. We need better computers, better algorithms. And then we are also working, I mean, this is something that you have to do with many other partners, and we are already working in some missions to do reconnaissance and deflection. So starting with the observational part, this is where I do most of the work. We have a wide telescope network. We have many different telescopes, but as you already know or can guess, is that we can do observations during the nighttime, not during the daytime. So then if you go to this plot that shows, I mean, it's a difficult one, but here is the sun, and the night part is what you can do ground coverage, so in blue. So there are still some gaps. This is going to be in red, a new infrared satellite to be working from space, but it's not going to look too close to the sun. So we are working in this part that you see that these are large NEOs, smaller, and then getting closer, and then smaller NEOs that you can only find if you look close to the sun. If you remember, Chelyabinsk was coming from the direction from the sun, so we couldn't find it because we didn't have such a telescope. So we are working to have it launched like in 5-7 years time. It will be in the Earth-Sun Lagrange 1 point, and it will be looking in, this is our star, the sun, and it will be looking around the sun to find these objects that till now, they are going completely unnoticed, unless they hit our planet, like Chelyabinsk, but then it's a bit too late. So then that was the observational part. Now we go to the assessment. We do orbit determination, impact monitoring, and imminent impactor warning. I already mentioned that this part 2 years ago in Redu. So the talk is in YouTube if you want to check it. And Detlef already did this part, so we can get to the coffee earlier, I hope. Just briefly, we are working on improving orbit determination and also impact monitoring, but it's mostly about developing new algorithms to understand how to process better our observations, how to deal now when we're going to have observatories on orbiting that is not the same as dealing with data from ground. So well, those are the things that we are doing in this part of assessment. But also, if you go to our portal, you will see many other things. We have in the information provision part, a newsletter, some close approach fact sheets. We publish some news. There is a full suite of different visualization tools, this NEO toolkit. So get a look on all the things that we do. And then we get, as I said, I try to focus more on the stuff that is interesting to us. So to the mitigation part. This I was lucky. It was already discussed the first day by Paul Wigward, but just to briefly mention, ESA is contributing with HERA. That is the mission that has been launched and is going to check how effective the impact was. So we know that this is possible. DART mission demonstrated that deflection is possible. Now we're going there to see how effective it was. I mean, what happened here? How much energy was? How much momentum got into the body? How much was just reshaping the object? So there is still a lot to learn from that impact. Somehow I got it not okay. Then also, if you went yesterday to the PAC quiz, you already know that there is an asteroid approaching us in 2029. It's going to be a near miss, so it's not going to collide us, but it's so close and the object is so large that it's very interesting. And it's the first time we're going to see such an object and how it behaves under our influence, how it reshapes, how it's affected by us, and also a good look into it. It's going to be so close that with the radar we're able to look through the first layers and see how it's in the inner part. And well, it's a lot of technology that was developed for HERA, so it's still to be confirmed, but we are quite confident, or we are really in good hopes that it will be approved, and this will take place. It's really short for space terms, but most of the work is already done. Other space missions that I think that they are cool and that we are working on. This asteroid inspection mission that, well, is a deep space CubeSat mission, so going to study an asteroid that is a bit farther from us. The actual scope is being evaluated, so not much to really say about it. But yeah, we need to go and see how asteroids look like to really understand how they are going to behave in case of a potential impact. Talking about deflection is not only about hitting objects, but you can be very precise using an ion beam, so really throwing ions against the object and move it slowly. We have just started this study. Yes, it's happening here in Nestec in the Netherlands. And as I've mentioned, it's important to study how they impact. And we have the moon that is a big target that we can look from our place. So there is going to be this ESA mission. It's not really a PDO mission. It's not Planetary Defense Office mission, but it's very relevant for us. Yeah, getting more and more in our topic, fireballs. We do some fireballs observations, although it's not our main goal, but we have 3 all-sky cameras. We are just installing one in Italy. They are used for press release. One of the mostly communicated, or it got most hits in the social media and everything of the space safety program. It was one video of a fireball. So there is a lot of interest in this topic. So we use it for public relationships, but also the data is shared. So if you're interested in the data, it's you can find it through All Sky 7, but the data is available for whomever that wants it. Also, we have this fireball information system. This is this web page that you can look for fireballs. It has a database. Unfortunately, it's not funded at the current time, so well, you will not find much updated data, but this is also something that is of our interest. And also, we can do fireball observations, Earth fireball observations from space with weather satellites. Some of them they're equipped by a Lightning imager. Europe has recently this capability in a Meteosat satellite. So there is already a paper, and we just got a graduate trainee to start working on doing this. The Americans are doing it with this GOES satellite Simon mentioned yesterday. And even there is a bit of overlap between GOES East and EUMETSAT Meteosat satellite. So there is a synergy to observe it with both systems. And this was supposed to be an animation, but I forgot and I sent a PDF. So you can find it somewhere. I mean, it's really nice to see how if there are storms, you see some lightning, some dots, and then you see a complete trajectory of a fireball. It's really, really, really cool. Other things that we are doing is that the European Commission has entrusted some activities to the European Space Agency um, to do physical properties observations, so to study how the asteroids are, especially the smaller end that are the most difficult to see, and we don't know that much about this smaller end that somehow overlaps with the meteoroid population. Like below 100 meters, the asteroids start behaving differently. I mean, the population is different. Also, we are developing a physical properties database. And then we are doing conferences, it's called networking, but conferences to gather communities. For instance, in 2022, we gathered all the people related to imminent impactors. Also in 2023, the emergency response agencies, because they are the ones, if we say, oh, there is going to be an impact, they are the ones that are going to coordinate all the civil protection. Last year, we did this near-Earth object size determination. And this year, we are doing just a bit advertisement. We are having next month in Italy this workshop on astrometric and radar observations of NEOs. I guess we have full house there, but it's still open for remote attendance. So in case it's of your interest, of your topic, amateurs do contribute for astrometry. So it's a topic that you could work with us. Another activity that we are doing is lunar impact flashes. We have a contract with Leota, with a telescope in Greece. They restarted in August after a couple of years that they were not working in this, and now they already got in 17th of August. So in the previous lunation, they already got the first lunar impact of this new season. So we are also doing that. And I guess I have a couple of minutes more. We also observe the objects when they are out of the atmosphere, or at least try. We did a search. We did not find any Taurid meteoroid, but we were looking for it with one of our telescopes. We also train because, unfortunately, there are not that many close approaches. So we train with missions that we know exactly where they are, so we can do the tracking, and it's training for us. And also they become eventually artificial meteors. They re-enter. So we do the tracking with our telescopes, and we can go as deep as when they are only 3,000 kilometers away from us. So these are different things, consultancies that we do for other groups, other colleagues in the agency. And if we want to talk about like really specifically meteor activities that we do, we have the work done by Michal, that I don't see, there he is. So this is part of his thesis. If you have questions, this part ask Michal, but this is what he's currently doing to understand or to constrain the fiber flux density, how many of these objects are out there, and also characterizing the cameras. And that's all or many of the activities. So if you have any question, I'm very happy to answer them.
Let's thank Paco.